Thank you. So I owe you one question last time. Okay, let me check. It's regarding the questions from exercise 2, where we have the questions for fail, but my calculation was for success. So I would like to correct that before we start. Question 2. That last one. Exercise 2, sorry. Exercise 2. Yeah, this one. Okay. So last time my explanation was find the probability at most one camera fail. Okay, so I did this. So this is wrong. The question asks for the fail if the camera fail test for 1. Okay, so how do I do this? Okay, so having said what we have the 3 diagrams and the probability distribution for this particular equations, okay, so I would like you to understand that, okay, for this part, we are talking about success of how many success? There will be 3 cell phones, so there will be at most 3 success where all the camera successfully okay. Means that if I draw the line for the success, just to give you the idea how the success and the failure came in. So if I'm talking about the success over here, okay, from 0 success, 1 success, 2 successes, 3 successes, okay. So the question asks if at most 1 camera fail. What does it mean by at most 1 camera fail? If I'm talking about success over here, okay, let's say success beneath, and the red one is for the failure. Okay, for the failure, if 0 success mean how many fail? If 0 success, 3 fail, right? For 1 success, there will be 2 fail. For 2 success, there will be 1 fail. For 3 success, there will be 0 failure. Okay? And what does it mean by at most 1 camera fail? Means that at most, the largest will be 1 fail. Can it be 0 fail, class?
No.
Think about it again. Can it be 0? Because it says at most 1 fail. Means that it could be 0 fail and it could be you have 1 fail. Means that kalau cakap bahasa Melayu dia, paling banyak dia fail 1. So maknanya kalau paling banyak 1, dia boleh jadi tak ada fail langsung. Means that you are going to consider this particular to what we call consequence or the occurrence of this particular test. So means that you are going to consider 0 failure and 1 fail. Okay, so how are we going to do this? So in this case, okay, so if you don't want to confuse, say y is equal to number of fail. Okay, because x is the number of success. Okay, just to make sure you don't mix up. So you are looking forward for py at most is less than or greater than? Is less than or equal to 1, right? Okay, so if less than, y is less than or equal to 1, okay, so if the failure is if the success is what? Success is 0.8, so the failure is 0.2. So you are going to have this, means that you are going to have py is equal to 0 plus py is equal to 1. Okay, so then find the probability, then you add these two. So can you find the probability for y equal to 0? No failure at all. So what would be the probability for no failure at all? Look for no failure.
30,512.
Uh, look for zero failure. That will be 0.8, 0.8, 0.8, right?
Yes.
Yes, 0.8 multiply 0.8 multiply 0.8 plus 1 failure. So you are going to consider, because look at this particular part. So you are, to be easy, look at this probability distribution. Look for 2 and 3 to make it easy. So you have 2 and 3 is over here, and the probability is this one. Okay, so add these two. So this one would be y equal to 1. So make it easy, just based on the probability distribution. So you are going to have 0.384 plus 0.512. So you will get, what's the value?
0.896.
0.896. I hope you are correct. So I hope everyone else can check. So 0.896 will be the value for at most one camera fail. So what will be the probability? What will be the likelihood for this particular one camera fail the test? Is it less likely to occur, or it will be high chance it will occur?
High chance.
High chance of what?
High chance to occur since 0.8.
High chance for what? For what to occur? High chance of what? Look at the question. High chance of what?
High chance of failure to occur.
High chance for one camera fail the test. Okay, so or you can say there will be likely that one camera fail the test. So the probability value is high. So most likely only one camera will fail the test out of the 3 camera. Okay, I hope you can understand this part. So hopefully you can revise again these particular questions. And this is wrong. So please consider this particular answer for one camera fail the test. Okay, so if you don't have any questions, let us begin with the second part of our second chapter. That will be continuous random variable. Okay. So under random variable, last time we have seen how discrete probability distribution can be found. How can we find the probability mass distribution? So last time I have introduced you the words probability mass distribution. What is probability mass distribution? Can someone tell me which part, or what does it looks like when we say probability mass distribution? Class. Which part? Which one that you call as probability mass distribution? Which one? Which one do you call the probability mass distribution? Is the tree diagram, or is the table this one, or is the calculation of your probability? Can someone answer me? Which one is the probability mass distribution? Plus, just try, okay? It's okay if you got wrong. I will just correct you. I just want to know which will be your guess. Is it the tree diagram, or is it this table, or is it this one, all the calculation here?
The table.
The
Why the
calculation.
table? Why the table first? Why the table?
Because it's the accumulation of the tree diagram.
Okay, considerably right. So it's not the calculation, yeah? Okay. Probability mass distribution shows you how for each of the occurrence, what will be the probability. So for each of x value, what will be the probability involved. So this is what we call as the probability mass distribution. Okay, now for discrete, we are going to take this to help us for our calculation of our probability value. Okay, see how this probability mass distribution is important for you to calculate your probability value. Okay, and of course from this the probability mass distribution came from this particular what we call tree diagram, just to help you out with the probability for each of the event. Now what if we are talking about continuous random variable? Okay, what do we call that then? So for continuous probability distribution, the one that will help us in order to find our probability distribution, okay, what would the value for the probability if you are given x greater than something something or less than something something or in between something some values. Okay, so this is what we call as probability density function. Okay, what is the difference between this? Okay, despite the different of discrete and continuous, okay, we know that the difference between these two, it's obvious. Okay, so what are the obvious things? Okay, so let us look afterwards. Okay, now we are going to continue with continuous probability distribution. Then we see how cumulative distribution function for this continuous probability distribution. And finally, how we can find the expected value, the variance, and the standard deviation. Okay, that will be our main things for our class today. Now, let us go back to the basic of what continuous probability distribution. Okay, a function with values. Okay, a function with values means that I have a function and this function got some values. Okay, defined over the set of all numbers is called probability density function of the continuous random variable x if and only if this probability, okay, from a to b is given by the integration of this particular function. Okay, what is the difference between discrete and continuous? For your information, just to give you an idea how this particular what we call integration came into your process. Okay, we are talking about last time, remember the difference between when we discussed about random variable, the difference between discrete random variable and continuous random variable. Your continuous random variable is continuous, means that it will be along the line. Okay, it can take any values, 5, 5.2, 5.5, 6, 6.3, any values on the line. Okay, if I can reflect that line in terms of a distribution, for example, just take this as an example of the distribution. Okay, this beside of what we have in discrete probability distribution, the way we find the probability value for continuous is this way. Let's say we are trying to find the probability from A to B. Okay, we remember we are talking about probability that x is greater than or equal to A and less than or equal to B. So where this A and B is, okay, we can assume, let's say this is where A is and this is your B. And we know that we are talking about continuous random variable and it can take any values on the line. Okay, it can take any values on the line here, to be precise, any values. But now we are talking about A and B. So we have our A here, we have our B here. Then we are talking about what would be the probability values inside this particular shaded area from A to B. And this is where how we can find using the integration of the function. Which function? This is what we call as our function. This is given by certain function, and this function in your case will be given to you. Okay, so a function of x, we have to integrate with respect to x from A to B, and you can have your probability x that you are looking for. Okay, understand class? Understand class? Okay.
Yes, sir.
Okay, so this is how we, okay, thank you. So this is how we find our probability density function. Okay, so this is what we call probability density function. Okay, all these are what we call probability density function. How we can find this probability? We have to integrate, okay, the function according to what values that we are looking for. That will be the first understanding that you must have with you. Okay, next. What will be the next consideration for this particular probability density function? Okay, the first one, the function will always greater than or equal to 0. This is the same as what we have in discrete continuous, this discrete probability distribution. Okay, it must be greater than 0. It cannot be less than 0. Okay, any probability must be greater than 0. And in our case, okay, the probability value or the function, okay, is greater than 0 for from negative infinity to positive infinity. Means that if I go back to my probability density function, I can have as smaller as negative infinity for my lower boundary, and for my upper boundary, it can be as positive infinity. Okay, so it can be from these two values. And if I were to be specific, talking about A and B, then we are talking about A and B. But obviously, it will be greater than 0 for negative infinity to positive infinity. That will be the first, what we call syarat lah, okay, or what we call condition. The second one would be, okay, the integration of the function of x with respect to x is equal to 1. This is the probability value. Okay, as usual, the probability value cannot be greater than 1. Cannot be less than 1. It should be equal to 1. Okay, so that will be the same definition as discrete probability, discrete random variable. Okay, so the same concept as what we have with discrete, the same with continuous random variable. Now, example 1. Let x be a continuous random variable with the following fx, and this fx is what we call as probability density function. Okay, when we have fx, a function with values fx defined over the set of all numbers is called probability density function. Okay, so afterwards I'm just call this as fx, and when we say fx is reflect the probability density function, and it reflect this particular things. Okay. Sorry for my voice, it's not really clear this morning. Okay, now you're given the function of what I said just now. The probability density function will always be given to you with the condition of the values that involve in your probability density function. In this case, you are given 3 over x, 3 over 4 multiplied with x squared plus 1, and this part, if I can imagine for you, let's say this is the distribution, and if you're talking about from 0 until 1, okay, this is the function that involve 3 over 4 x squared plus 1. Okay, so this is the function that involve, and that reflect from 0 until 1. And if you can see here, 0 is included, 1 also is included, and 0 otherwise, means that the rest is 0. Okay, just for you to imagine how the probability density function involved. Okay, so verify whether this distribution is a probability density function. We know that when we say it as probability density function, it should have this particular, it should meet this particular condition. Okay, so how do we do this? To verify whether this distribution is a probability density function. Okay, now let me erase this because I need the space. Now, how we are going to do this? Okay, we know that the density function from 0 until 1 is given by this particular function, and if it is less than 0, which means not including 0, and is greater than 1, okay, the function probability density function will be equal to 0. So how do we verify this? So in order to verify this, we have to show that this particular condition is met and we get 1 when we integrate them. So for A, we are going to integrate from 0 until 1, okay, because you are given the condition 0 until 1 is given by 3 over 4 x squared plus 1, and you have to integrate with respect to x. And this should equal to 1 to satisfy this particular condition. And of course, this one automatically must be met, okay? So usually if you get this, you can prove that you get 1. So it means that the first condition is also met. Now, in this particular case, you have to remember how to integrate, okay, function, especially quadratic function or any function of x, or sometimes you might be given an exponential function. So at least you can have some what we call revision that involves certain integration involving any function of x, including maybe exponential function and so on, okay? I believe for the example or for the exercises, we are going to have a function of x and the exponential function, okay? Just see how we can do this, okay? So in order to integrate, since we have our coefficient here, we can take out our coefficient and it will be 3 over 4 and we integrate with respect to x for x squared plus 1, both with respect to x must be equal to 1. Then we start integrating them, okay? So we have x squared. Remember how we integrate? If we have x to the power of a, we integrate with respect to x. This is a, not 9. This is a. So if I integrate this, it will be x, the power will be increasing, and then the new power will be the denominator, a plus 1. Since this is what we call exact integration, an integration with certain value, so there will be no need to have plus c, okay? So this is an exact integration, so that's why we have. Then we will have x squared, it will be what? X to the power of what? Class?
X power of 3.
3 over
3.
3. What about 1?
No need, since there is no x.
If I differentiate 1 with respect to x, this is differentiation. This will be 0. If I integrate 1 with respect to x, I will get x. Yes. If I integrate 2 with respect to x, I get 2x. Okay. If you got number, if you integrate, that number will have to multiply with the x. With different, if you have power to your x, let's say x to the power of 4. If differentiate with respect to x, you will get x to the power of 5 over 5. Remember that, okay? What if I have something over here? Just take out here as what I did here, just not to give you any confusion. So 1 integrate, you will get x, and replace with the value for 0 until 1. Okay, so this one should equal to 1. Okay, then solve for the x cube over 3 plus x, replace with the value. So you will get 3 over 4. You will get 1 over 3 plus 1. The first, that will be for 1, minus the second is 0. 0 over 3 is 0, plus 0 is 0, is equal to 1. I did all the step one by one just to make sure everyone remember. I believe some of you may have forgotten how to do the process. Okay, so when you replace the value of 1, you should have minus when you replace with the second value 0 insert. Okay, so in this case, you will get what? 1 over 3 plus 1, you get what? It will be 3 over 4 multiplied with 4 over 3, right? Am I right? Am I right? Yes, okay. So cancel out. So you get this one is equal to 1. And you have verified that your given probability density function is actually a probability density function because it fulfilling the condition. Because when we solve from 0 until 1, it satisfies the probability value is equal to 1. Now, from this particular probability density function, you need to find what will be the probability if this particular x takes certain value for 0.2 until 0.4. So how do we solve this? Okay, if you can remember how we calculate the probability for discrete probability distribution, definitely it is 360 degree different from what we have previous. Okay, so most of the time here we are going to use our function to solve for our probability distribution that we are looking for. Now, how do we do for first questions? Okay, for the first question, you are looking for the probability from 0.2 until 0.4. Okay, now what you are going to do, look at your given probability density function. Where does this value takes in? Okay, so if you check, it is not otherwise because the condition for from 0 until 1 is given by this particular function. And 0.2 as well as 0.4 is inside this particular interval. Correct, class? It's not this one, right? Class? These two values are inside this particular interval. Am I correct, right, class?
Yes.
Yes, okay. Since we know that this particular function applied for this particular equations, so we are going to use this in order to help us out to find the probability for x is between is greater than or equal to 0.2 and less than or equal to 0.4. So for B, we are going to find the probability from 0.2 until 0.4, the same as what we have here. So 3 over 4, and then x squared plus 1, integrate with respect to x. And we know that when we have integrate, we are going to have 3 over 4. We have x cubed over 3 plus x. And we have this value from 0.2 until 0.4. Okay, so replace inside. Okay, so replace, when you replace, you have 3 over 4. I need to write smaller because I have limited space here. So 0.4 cube plus 0.4 minus 0.2 cube 3, 0.2. Can you calculate, class? What is the value here? We will get what? 3 over 4 multiplied with what? Can someone calculate? Okay. Can someone tell me what's the value? Simplify this one minus this one. Am I correct? I got 82 over 375. Or you can simplify as 0.164. Do you get any other answer or the same as mine? Can someone verify?
Same, Doctor.
Same FU.
Okay, thank you very much. Okay, now let us how we can find for C. Now for C, look very carefully. Since this is a continuous random variable, so the continuation will base on the value involved in your calculation. And if you can see for the second question, the x value takes from 0.7 and above. See? 0.7 and above, but less than or equal to 3. 0.7 is okay inside this part, still inside in the first what we call function. What about less than 3? 3 is greater than 1. So this one is not the part for this particular 3 value. So otherwise is the one for 3. So how we involve these two particular probability or the fx for these two function for your calculation of your p x greater than or equal to 0.7 but less than or equal to 3. Okay, so let's see. So let me change the pen so that it will be obvious for you. And this for C, we are looking for, okay, for the first part is 0.7. So 0.7, okay, if you can see, if I can draw the line, you have 0 until 1. Okay, and then you have greater than, so here is 0, here is 0, and this one is 3 over 4 x squared plus 1. Now, for this part, for the first part is from 0 until 0.7 until, because we are talking about this particular function. So we are going to take from 0.7, maybe somewhere here is 0.7, until 1. Since this is, satisfying this particular function for this part, so it will be 1 here. And the function, as usual, it will be 3 over 4 x squared plus 1 dx. That will be for the first part. What about the second part? For the second part, we know that we are talking about greater than 3, less than or equal to 3. So let's say we are talking about 3 here, and we are talking about less than or equal to 3. So it will be 0, the one that we are talking about, 0, and we have to integrate with respect to x from what value? From
1 to
1
3.
until 3. Yes, correct. Because we stop at 1 and then we need to find until 3. So as usual, so this one will give you 0 because you got 0 here. So this one 0. And solve for this part, for the first part. So that will be 3 over 4. That will be x cubed 3 0.71. So calculate, class. What do you get here? 1 over 3 plus 1 minus 0.7 cube 3 plus 1. Plus, x, right? It should be x here. So x here, sorry. So this will be 1. And this should be 0.7. Okay, can you calculate, class? 0.7. Okay. So what do you get here, class?
0.389.
0.389. Can someone verify? If I solve this, mine I get
0.38925.
0.389.
0.389. Dot, 1. This one will be 3 over 4. And then this one you will get 3 over 3 is 4 over 3 minus this one is what? I think I made the mistake. Okay, 0.7 cube divided by 3 plus 0.7. Okay, 0.8143. Okay, so let's say 4 over 3 minus 0.8143 multiply with 3 over 4. 0.389293. Is it correct?
Yes, Ada.
Yes, correct, sir.
Okay, thank you. So mine is wrong. Okay, here it should be 0.3893. Okay. Okay. You got did you got the idea of how to find the probability given from the probability density function for the first example? Okay, so this is how we do it. Okay, let us see for the second example. Is there any difference? Okay, for the second example, let x be a continuous random variable with the following probability density function. Now you are given the probability density function, and for x greater than or equal to -1 and less than or equal to 1 is given by this one, and the rest is 0, means that less than -1 or greater than 1 is 0. Now you have to evaluate C. How to evaluate C, class? Here, to evaluate C, we know that any probability density function must be equal to 1 for any given value, for any given value in the condition. So in this case, you have to prove that this particular condition, if you integrate them with respect to x, you will get equal to 1. So what you will do, okay? So in the first place, you are going to integrate this C. Let us just take out C outside, because C reflect a constant and it will be a number. It will be a value. So the given function would be 2x cubed plus 5. Make sure you got the bracket, because the two what we call the two function here will be integrated with respect to x. If you did not put the bracket, it will be a wrong way how to solve the mathematical function. Okay, and you have to integrate from -1 until 1, and this should be equal to 1. Can everyone try at the same time? So this will be 2x to the power of 4 divided by 4 plus 5x, and we need to find the answer from -1 until 1, and this should give equal to 1. Okay, so you have C, you will have 1 over 2, so 1, you will get 1 over 2 plus 5 minus -1 to the power of 4, you will get 1 over 2 minus 5 multiply with 1. So 5, so you will get -5. So that's why you have here 5, -5. Okay. Okay. So solve this. This should be equal to 1. So what do you get here? You will get here The first one is 11 over 2 minus what? 9 over 2. Okay. So let me know if I got wrong. Okay. 11 over 2 minus you will get plus, right? C 20 over 2 equal to 1. Okay. So here you will get 10 here. So your C value will be 1 over 10. So that will be your C. Now we know that our constant C is equal to 1 over 10. Okay, class? So that's how we evaluate C. Evaluate C means find what will be the value for C. Okay, so this is how we evaluate the C value by integrating the function from -1 until 1, which is equal to 1. Any question here, class? Any question, class?
No, Doki.
Okay, thank you. Just respond to me no or yes. It will be just okay to me. Okay. Next, we are going to find the probability for x is greater than or equal to 0 but less than or equal to 1. Okay, so how do we solve this? So for number 2, okay, we know that, look at the function. Okay, 0. Where does 0 falls between? Where does 1 falls between? So basically, it's still inside this particular function. 0 is inside here, and 1 is also considered in the function. Okay, now our task is just directly solve the equation. Is there any is someone writing something in the notes? Because sorry, I cannot see the chat room. Can someone tell me? Is someone writing something inside the chat room?
No, doctor.
No, like that. No, like that.
Okay, thank you. 1 over 10, so that will be your C. And we are going to integrate from 0 until 1 simply because 0 until 1 is inside this particular condition. So directly 0 until 1. Okay, so and the function would be 2x cubed plus 5 integrate with respect to x. And then solve for this, we know that this will be 1 over 10 and you will get x to the power of 4 over 2. I'll just take this answer, plus 5x, and then put the value from 0 until 1. Can you solve for this one, class? Solve for this, class. I'm going to stop for a while. I would like to see how many of you inside my class now. 160, okay, 170, okay. For those who did not attend my class, please give me your reason, a letter with reason why you are not attending my class, so that I will not going to consider you as absent. Okay, any absent must give me a letter, just to give not to give you 0 for your attendance. Okay. Okay, have you finished? So this one is 1 over 10. This will be a 1 over 2 plus 5 minus 0, right? So this will be 1 over 10, 11 over 10, right? 11 over 10 or
11 over 2.
2, sorry. Okay, thank you. This is 10, this is 2, so you will get 11 over 20. Okay, or if you can get okay, any decimal point, that will be okay also. Okay, so this one is easy. Now for the 2 example, I hope you can understand how we can verify a certain density function is actually a probability density function, knowing that it fulfill the density function is equal to 1. That will be the first one. And from the given density function, with respect to the condition of the x value, you can find what will be the probability value of the given equations. Okay, now we have exercise here. Okay, we have exercise here. Why don't you try exercise number 1? Okay, you are given let fx is equal to 12.5x minus 1.25, where x is greater than or equal to 0.1 but less than or equal to 0.5. Find px 0.2 less than 0.4. Can you try this, class? Very quick, because it's straightforward. Okay. So number 1, you are looking for 0.2 until 0.2 until 0.5. 0.4, sorry. Okay, 0.2 until 0.4, and if you check, 0.2 is above 0.1 and 0.4 is below 0.5, so we are going to use this function. So it would be 12.5x minus 1.25 integrate with respect to x. Okay, so you will get what? You will get 12.5x squared over 2 minus 1.25x, and you have to definite integration from 0.2 until 0.4. Okay, replace all the values inside. (12.5) 0.4 squared over 2 minus 1.25 0.4 minus 12.5 0.2 squared over 2 minus 1.25 0.2. Okay.
Dapat 1 ke doktor?
Huh?
Dapat 1 ke?
Yes, it should be 1. Okay, it should be 1. Just to give the value before 1. 12.5 multiply with 0.2 squared divided by 2 is 1 over 4. 1.25 multiplied with 0.4 is 1 over 2. I always like to show the work, the process, so that everyone who did not understand can understand what is happening. Okay, for those who just got the answer, thank you very much. 1 I believe is correct because I got 1 also as well. So 12.5 multiplied with 0. Sorry, this one is 0.4. 12.5 multiplied with 0.4 squared divided by 2, you will get 1. Here is 1. It's 1 over 4 minus 1 over 2. Here is 1. Okay. Minus 1.25 multiplied with 0.4 half. Okay, I believe you get 1 over here. Okay. Any correction for my answer here? Okay, 1/4 minus 1/2 divided by 4. Did I make any mistake here? 1.25 multiplied with 0.4 is half. 12.5 multiplied with 0.2 squared divided by 2 is 1/4. 1.25 multiplied with 0.2 is 1/4, sorry. Here is 1/4.
Point 5 lah dah.
0.5 Ada yang dapat 0.5 ke?
Ya dah.
Betul Saya punya jawapan asal ni I think I got wrong, okay? So betul lah sorry. It's not 1 So 0.5 because this one give you 0. So 1 minus half will be 0. 0.5, okay? Thank God I check. Okay, thank you very much for your answer. So please double check your work wherever possible. So that will be number 1. What if for number 2? Now we have exponent. Okay, what if we have our exponent and you are given the probability density function is for x greater than 6, it will be given by exponent negative x plus 6, and for the rest of if we are talking about 6 here, greater than 6, this is 6 here, so you are talking about exponent negative x plus 6 here, and the rest is 0. Okay, now we are talking about finding the probability x greater than 6. Okay, obviously you're going to take this function as your calculation. So let us try this. Okay, number 1. Let me write a bit smaller since the space is limited. Okay, so number 1, we have for e negative x plus 6 from is greater than 6. If we have greater than 6 means that greater than 6 you will have from 6 until infinity, because we know that the boundary greater than 6 to this part, this will be positive infinity. Okay, so that will be our first understanding, because there will be no boundary greater than 6 and above, means that greater than 6 and above, what will be the stopping point? That will be positive infinity. So in this case we have e to the power negative x plus 6, and we have to integrate with respect to x. So how do we solve this? Remember last time when we have integration of ex, this simply will be ex. What if we have ex e to the power of 2x dx? What happened? This will be e to x over 2. What if we have e to x plus 6? How? If I use the substitution method, I have u is equal to negative x plus 6. Okay, so du dx is equal to negative 1. I differentiate negative x, I get negative 1. And since I have dx here, I need to change into du. So du is equal to negative dx. Or dx is actually negative du. Because I need to change this into U. Okay. This is equal to U. Sorry. So when this is equal to U, then this one should be replaced by U. So in this case, we will have integration from 6 until infinity. E U, since I have negative here, I put negative here, d U. Okay, so I can integrate simply, this become negative E U from 6 until infinity. Okay, now we got the answer. Replace back our U in terms of X. You will get negative E, then negative X plus 6, 6 until infinity. Can we change, can we replace the value, find the definite integral for this particular equations? So we'll get what? Negative E infinity, negative infinity plus 6. Let me change the infinity so that it will be much clearer. So this one is negative infinity. Okay. Minus e to the power of 6 plus 6. Can you solve, class? What is the answer for exponent to the power of negative infinity? Can you use your calculator?
It need to clarify as 0.
Yes. Any, okay, I write in red pen. Okay, e to the power of negative infinity, it will be 0. E to the power of infinity, you will get what? You will get what?
0 also.
Huh? 0 or 1?
1.
1. It should be 1, right? Let me double check my notes. Yeah. So. No, not 1. That's why I need to check my... It will be infinity. Okay. Exponent to the power of negative infinity will give you 0 because it will be very small value. Okay. If you don't, if you can try exponent to the power of negative 100. What do you get? Exponent negative 100. You will get 3.7200 to the power of 10 to the power of negative 44. Means that you got 0.00000043 times before you meet 3.3720. Okay, so that's why exponent to the power of negative infinity will give you 0. If you put infinity exponent to the power of 100, for example, you will get very big value, 2.688 to the power of 10 to the power of 443. So it will be a very large value. So that's why we say exponent to the power of infinity will give you infinity, exponent to the power of negative infinity will give you 0. So in this case, will give you 0. What about this one, class?
Doctor,
Yes.
exponent to the power of negative infinity is 0. Exponent to the power of infinity is 1.
1 ke infinity? Why 1? Why 1?
Exponent, kalau exponent power negative infinity 0 kan?
Ya, betul.
Kalau exponent power of infinity,
It should be infinity. Try your calculator, exponent to the power of 100. You will get 2. If I can...
2.68
Yes.
times 10 power 43.
Yes, This one, e to the power of 100 will give you 2.688117142 multiply with 10 to the power of 43. Means that you have to move 43 times here. So it will be very large value. Imagine if you have e to the power of 200. What do you get? Try. It will be even larger. You have 7.2259 blah 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 times 10 to the power of 86. Then you move 86 times here. That's why it become infinity. It become a very large value. So
Okay.
consider that as infinity. Okay. So that's why here you get 0. Here you get what? Negatif dengan negatif dia jadi positif. E to the power of -6 plus 6, you will get e negative to the power of 0. I'm sorry those who understood this, I have to revise again because some of you may not remember how the process can be done, okay? So here, you will get e to the power of 0. So e to the power of 0 is what? Always equal to 1. So that's why you have 1 over here. Okay? Okay. Now,
Doctor, sorry to ask.
Yeah.
So kalau kata if like E exponent infinity equals to infinity kan?
yeah, betul.
So the last answer memang dia akan remain infinity tu juga?
Biasanya kita akan biasanya kalau infinity we will remain as infinity, but this is just an example, okay? But in your assessment we are going to give you certain value that you can verify, okay? If let's say it's still infinity, just write as infinity because there will be no way you can write e to the power of 200, but you can write this way. It's okay. Or you can write as approximate as infinity. Also considered right. Okay, because I'm going to I'm the one who are going to mark your answer later on. So the way I give you, the way I teach you is the way how you should answer your questions, or you can follow others how you can answer the question as long as the concept is still correct. Okay. So for B, I want you to try, okay, try on your own. And in this case, still, we are still talking about from 5 until 8, okay? 5 until 8, so 5 is greater than, so 5 is here, and then 8 is here. So you are talking about here. So there will be 2 parts. So there will be integration for 0, dx, integration for here. Your function is 12 point, e to the power of 12.5 x minus 1.25 with respect to x. Okay, and from 0 here, okay, and this part is 0 and this part is this one. Okay, so do you want to take a rest, class? What is the time now? 9:37, almost 1 hour.